In this video, we're going to use Microsoft Excel for a hypothesis test for a population mean. Here's our first question. We're given the test, the hypothesis test, that mu is equal to 40 versus h1 mu is less than 40. A random sample size of 25 is obtained from a population that is known to be normally distributed. Complete parts A through D. So it's important that either we have one of two things or both, that it's normally distributed, or the n is greater than or equal to 30. So we have 25 here, but it says it's normally distributed, so we're fine. Okay, and then they have the t distribution values right here, so you can click that or you can see the sheet, but let's enter this into our Excel document first. So we have, this is our mu naught, 40, then we have 37.9. So here's my my Excel document I have ready. And I have 40 for mu naught. These are my enter cells, so I enter there. 37.9, I think. And then our last one was 11.1. Okay, and we have 25. 11.1 and 25. So these are all the numbers that we're going to be inserting, and then the calculations will be done here to figure out these values. Over here, what I've done is I have it set up in case I have some data that I have to paste in here. Then I'm going to calculate the mean, calculate the standard deviation, count them up, get the n-1, and then do this t-statistic over here, and then the p-values. So this one will be only used for complete calculations on this data. It will use the same mu naught, though, over here. Okay, the easiest one right here, I guess, n-1 for degrees of freedom. So we take this box, always subtract 1 from it. We need the t-statistic, which is this formula or equation here. So the mean minus mu naught, we want that in parentheses for the numerator. So parenthesis, mean minus mu naught, okay, divided by, parentheses again, the standard deviation here, divided by the square root of n. Hit enter, and hit enter one more time, and then this will be the t-statistic. Now we need to check the level of significance with that problem, so in 0.945, and it's negative, so -946 basically, -0.946, and it says the researcher decides to test this hypothesis at a level of significance of 0.05, determine the critical values. Although technology or t-distribution table can be used, find the critical value in this problem using the t-table given. Okay, so we can use the t-table then at 0.05. We need the degrees of freedom. It's always one less than that. I grab the t-table and go to 0.05, go down to 24 degrees of freedom, and then we match that up. It says 1.711. Now that's positive 1.711, but the answer is negative. The reason why we have a negative value for this t alpha for the critical value is because, let's look at our little map here. We see that on a left-tailed test, which we're doing with this problem, it was less than. The critical region is to the left over here. So that t-value, t-alpha, needs to be a negative t. So when you're looking at that and you're doing a left-hand tailed test, make t negative, and then we check the tailed test to see if our t-statistic is less than that negative t critical value. If it is, we reject the null hypothesis. This one, if we look again with negative 1.711, is not less than that. Less would be further to the left, like -2. So here we draw the graph. It would be this one, and then will we reject the null hypothesis? No, because the test statistic does not fall in this region. Our test statistic falls over here someplace. So it has to be less than that to reject the null hypothesis. In this hypothesis test question, we're going to look at given some data, and then we look at using the p-value approach. So here's the data. So let's copy that data so I can get it into my Excel document. And basically it says the mean waiting time of a drive-through fast food restaurant for a time an order is placed to the time the order is received is 85.9 seconds. A manager devises a new drive-through system that she believes will decrease the wait time. As a test, she initiates the new system at a restaurant and measures the wait time for 10 randomly selected orders. The wait times are provided in the table. Complete parts A and B below. Okay, because the sample size is small, the manager must verify that the wait time is normally distributed and the sample does not contain any outliers. So here we have a problem. We have to look at the probability plot and box plot. There aren't any, it's normally distributed because it follows the line, and there aren't any outliers, so we're totally fine to go forward. It says, is the new system effective? Conduct a hypothesis testing p-value approach. Level significance of 0.05. So basically the initial was 85.5, and she's testing, she says, it will decrease, so it's a left-hand tailed test, less than 85.9. Find the test statistic. Okay, we got the data. Let's go to the Excel chart. I'm going to paste it in here. Okay, now we're going to start filling these out. The X bar is just the average, so average of these values. Enter. Standard deviation. Well, that's going to be all this right here. So we can't quite compute it yet. We need to find the deviation squares. So I'm going to take the xi here, subtract it from x bar, and square it. I'm going to put a dollar sign on that x bar so I can pull that down then. Then I can pull this all the way down. And then we need to sum that up. So at the bottom here, I'm just going to write sum of all this information here. Okay, so then that's the sum of those. So now I can complete this standard deviation. It's the square root of the numerator, which is the sum of all that, divided by n minus 1. I'm going to have n minus 1 right here, so I'm going to put that to that box. I'll fill that in a moment. Okay, and hit enter. It's not coming up because I need to do that. Let's do this equal to count, so it will count them for me from here to here. So that'll be automatic, and then we'll take this one. You can just type in 9 if you want, but I always like to have it sorry about that. I always like to have it automated, so I'm going to do equals this box minus 1. Okay, then this updated for me. Now let's do the t-statistic, because we need the t-statistic to get the p-values. So, same thing as over there, it was x bar minus mu naught. So, x bar, I'm going to take this x bar here, minus, and then this mu naught over here. Or you can make another box up here maybe for mu naught if you want to. Maybe we'll do that, and we'll just enter it above. And then we'll take parentheses on the bottom, the standard deviation divided by the square root of the n value, and that parenthesis and that one. And I'm going to fill in my mu naught right here. So I'm going to copy this thing over here and paste it just to make another little box. And this will be my mu naught, and that was 85.9. So if I fill that in, now our t-statistic has been updated. Negative 1.633. Negative 1.633. Okay? So a little bit of calculations there to get that. Now we want to get the p-value. So when we're looking at the p-values, this is the kind of test we're doing here. We're doing the left-hand tail test again, and we're looking for this area to the left. And if the p-value that we get is less than the significance level, then reject the null hypothesis. So we got to find that area to the left of that t not, that t-statistic. And how we do that here, there's a nice little function in Excel. It's called t.dist. Now t.dist is the left-hand tail, returns the left tail student's t-distribution. So that's exactly the one we want. You can see there's a to tail and a right tail, and those are the ones we're doing for those later. So we'll do that one. The x value is the t-statistic that you need. So we click this box. The degrees of freedom are always the n minus 1, so that box. And then cumulative, we write true. And then we hit enter, and this will be our p-value, 0.0685. 0.0685. We go back here and said find the p-value, 0.0685. Now we make our conclusions based on that p-value. Is our p-value less than the significance level that we have chosen for us? The significance level, remember, was 0.05. So this is not less than it. So the p-value is greater than the level of significance, so there's not sufficient evidence to conclude the new system is effective. So we do not reject the null hypothesis. We do not reject the null hypothesis. All right, let's go back here and just fill in these other values here, and we'll do it for this one as well. It'll be the same thing. So basically, except it's using these values up here. The greater than p-value, if we needed that, it would be equal t.dist, and then it would be the right, rt, and returns the right-tailed portion. We'd use this t-value, and degrees of freedom would be that one again. And we don't have that true to enter. Okay? You can see that those two basically should add up to 1, right? The right tail and left tail. Because it's of this one value. Now when this becomes a positive t-value, that would be the right tail that you're looking for, and it'll be this one, a greater than. Now the two tail, that's equal to t.dist, and then you have a two tail dot 2t, the t-statistic, comma, the degrees of freedom, and that would be in both tails. Now we have an error here because this value is going to be a positive value always. So in case we do get a negative value for this, let's go into here and just make this the absolute value. So ABS of that value right there, and then hit enter. And then, because it's looking for a positive value, and all it does is basically just double it. So it's basically doubled this one, but it's always looking for the positive value. And then we can just fill the values out over here using these values the same fashion, and it would be complete for inserting your own data or having data collected this way. So that's how you complete hypothesis testing for a population mean.